All right, guys. So welcome to our mathematics lecture class, and I'm sure you guys have have revised the first lecture class we had on complex numbers. So for today, we'll move further on complex numbers. In short, we are just going to conclude this particular topic. So please make sure that you watch the lecture class, which is on YouTube, and you also make sure that you are able to watch the revision class, which is also on YouTube. Okay, so we'll continue with division of complex numbers. So if you look at complex numbers, like we stated yesterday in our last lecture class, so when we talked about complex numbers, we said that complex numbers have two parts. There is the real part, okay, there is the real part, and also the imaginary part. There is the real part, and we also have the imaginary part. So these are the two parts that makes up the complex numbers: the real part and the imaginary part. And then one other important thing that we discussed last time when we were discussing complex numbers, we said let's say you have square root -1. So square root -1 cannot be worked on using real numbers. As a result, this was equated to an imaginary number which was given as I. So after that, we had to introduce a squared. We introduced a squared, so that square root and the squared went, so we had -1 is simply equal to I squared. Therefore, we concluded that I squared is simply equal to -1. So if you remember very well, I had to emphasize on the need and importance of you guys knowing this particular formula. So this was our brief summary of the class which we had before we even looked at finding the conjugate. Okay, we also looked at finding the conjugate. So what I'm saying here is something that you can find in our lecture class on complex numbers, the first part. So when you talk of the conjugates, let's say you have a complex number which is a plus bi. So if you talk of the conjugate, okay, if you talk of the conjugate of this particular guy, it is just simply equal to a minus bi. So you just change the sign there, or you can say -a plus bi. So the key is just for you to change the sign for one of these guys. So this is what we discussed, but today we'll go further and look at something else, which is simply division of complex numbers. So ladies and gentlemen, my emphasis is on you guys to make sure that you pay attention on this particular part, because it's very important. Okay, so I'll start with the example. So the example we are having is express the given complex numbers. Express the given complex numbers in the form a plus bi. So the question is, express the given complex numbers in the form a plus c ib or bi. Okay, so what we have been given, the first one we have been given is, let's say we have 3 plus 5i over 5 minus i. So this is the first one which we have been given, and we have been asked to simply express it in that particular form. Okay, so in such a case where you have been asked to express that particular expression or that particular complex number into that form, what they are just simply telling you is just for you to simply rationalize. In other words, in other simple terms, some lecturers will use rationalization, okay, though that has to do with rational numbers and such, but I'll use that term for the sake of you understanding. So in this particular case, we are just simply looking for a way we can get rid of an I outside downwards. Okay, we are just finding a way we can get rid of an I, which is the imaginary part, on the denominator. So the first point, the first way you can handle this question is finding the conjugate of the denominator. So you have 3 plus 5i over 5 minus I. So the first step is find the what? Find the conjugate of the denominator. Okay, find the conjugates of the denominator. Find the conjugate of the denominator. So you guys, who knows the conjugate of the denominator in this particular case? What's the conjugate of the denominator? What is the conjugate? Correct. So the conjugate of the denominator in our case is what? 5 plus 5v plus ci. Okay, so the conjugate we have found is 5 plus I. Okay, then the next step that you need to do is multiply. You need to multiply both the numerator and denominator by the conjugate. Denominator by the conjugate. Okay, so after you find the conjugate of the denominator, your next step is to multiply that conjugate by both the numerator and the denominator. In short, what I'm just saying is you're going to multiply 5 plus I, you multiply it by 3 plus 5i, and also you say 5 plus I, you multiply it by what? By 5 minus I. So with this in mind, you can easily work on. You can easily work on such that you're just going to say the numerator, which is 3 plus 5i, 3 plus 5i, open bracket, then you say 5 plus I. Okay, so that's what we have. So if you look at the last section of our lesson yesterday, which was how to multiply the conjugate of a complex number by that complex number. So what we discovered was the answer is just 5 squared minus, and then you say I squared. Okay, so this is what we had to discuss yesterday, and this is how the expression is supposed to. The reason why we are expressing this in this particular form, it's because we know that these two are just the difference of two squares. Okay, so before I move on, do we have anyone with a question? Please, if you have a question, feel free to ask so that we move at the same pace with the same understanding. Any questions, ladies and gentlemen? Ladies and gentlemen, do we have any questions? Do you have any question?
No questions, sir.
Okay, all right. So we can move on now and look at the next step that you are supposed to take when we talk of dividing the rational numbers. So we have that expression there, which is simply easy to work on, which is very easy to work on. So can someone help me with what is on top? What is on top?
We have 3 plus 5i
3 plus 5i.
close bracket.
Okay.
Open bracket 5 plus I close.
Okay, so that's what is on our numerator, and then the denominator, I'm sure it's something that was something like that. Okay, so from there we had to state that here these guys, they can easily be worked on, and then on top you can say 3 times 5, it's simply 15. Then you say 3 times I, it's just positive 3i. Then 5 times 5i times 5, it's just positive 25i. And then you say 5i times I, it is negative 5. It's negative 5, because we know that I times I, it's just negative 1. Then down there we had 5 squared. Okay, we had 5 squared, which is simply 25. And then we had I squared, which was simply negative 1. So negative 1 times that negative which was down is going to give you plus 1. Okay, so after you solve like that, you can easily work on the what? You can easily work on the like terms. So if you look at the like terms there, you have 5 plus 5, which is giving you 40, and then 3i plus 3i plus what? 3i. Do we have another I? There we have 25i. Okay, I think I did not include something there. Let me just redo it. I think I did not write the I.
5i times I, then it's supposed to be 5i squared.
Yeah, that's where I want to redo, because I wrote. So 3 plus 5, it's 15. Then 3 times I, it is plus 3i. Then 5i times 5, it is 25i. It's 25i. And then 5i times I, it's negative 5. Then over, 5 squared is simply 25. And then I squared is negative 1 times that negative, it gave us positive 1. Like terms, this times this and that are like terms, so this will simply be 10, and then this and that is going to be positive 28. So this will be positive 28. So 28i over 26. So after you write that expression, you can easily work on. After doing this working, you can simply express this expression in the form which we were asked. So here we are just going to say 10 over 26 plus, then there you are going to say I 28 over 26. So after you do that, you can simplify this one. You look for a number that is going to this one and that one. So in that case, it's a 2. So 2 there, it's 5, and 2 there, it's simply 13. Then you say plus, you can say I, 2 into 28. 2 into 28 is 14. 2 into 28 is 14. Then over 2 into 26 is simply 13. So this is just the same as I plus IB. So that's the answer. For those who are a little bit behind, so this part here, it's from the part which is on the previous slide, where I said the down part will be 5 squared minus I squared. I think I explained that. So what you need to understand is that 5 squared is 25, then minus I squared is negative 1. Then that one will simply give you 25 plus 1. So I skipped these stages and went as far as that. Yeah, so that's how easily you can work out. So this is our final answer for this particular question. Do we have any question, ladies and gentlemen, before we move on? Do we have any single question before we move on? Okay, it's more like we are all clear and okay. So let's move on and look at something else. Let's move on and look at number 2 of our examples. So this one is negative 4 plus 2i, negative 4 plus 2i over negative 6 minus 5i. Okay, so we have this as our question and we can easily work it out. So what we are going to do at this particular point is you're going to write the same question the way it is. So you're going to say negative 4 plus 2i, and then you say over negative 6 minus 5i. The first step, as usual, is to multiply both the denominator and the numerator by the conjugate. So in this case, the conjugate is just negative 6 plus 5i, negative 6 plus 5i, and then there you also have negative 6 plus 5i. So when you do such calculations, you can easily work out this expression by simply saying negative 4 plus 2i, and then close bracket you have negative 6 plus 5i close bracket over you have negative 6 squared and then minus 5i squared. After you work out that, you can easily work out this expression by saying negative 4 times 6 is just positive 24. Yeah, it's just positive 24. Then negative 4 times 5i is going to give you negative 20i. It's going to give you negative 20i. So after you multiply 4 by everything that is in the other bracket, you're now going to multiply 2i by everything. So this will be negative 12i when you multiply this by that, and then this times that is going to give you negative 10. Then over, you're going to say negative 6 squared is simply 36, then 5 squared is 25, and then I squared is negative 1, so it's just plus 25. So once you do that, you can go on to the next stage. So this stage you collect like terms. So you're going to say 24 minus 12i. 24 minus 12i. What's the answer? 24 minus 12i. Oh, sorry, 24 minus 10. 24 and negative 10 are the like terms. So 24 and negative 10 are the like terms. So 24 minus 10 is 14. And then you say negative 20i minus 12i is simply going to give you it's simply going to give you negative 32i. Okay, so this is over, you're going to have 61 down there. So if you work out this expression, you separate these guys, you're going to have 14 over 61, 14 over 61, and then you're going to have minus I, and then there it will be 32 over 61. So this is the final answer, looking at the fact that there is no number going to 14 and 61, and we also don't have a number going into 32 and 61. Ladies and gentlemen, do we have any question at this particular point? Do we have any question for this part? Florence, you don't have a question?
No, I don't have a question at the moment.
Okay. Frederick, do we have any question?
I'm okay.
Yeah, okay. Okay, let's move on and let's quickly look at the last example. So let me look at the last example, then we'll surely do the other parts. So the next example is not different from the friends, just the same thing. So this is our number 3. So for our number 3, we simply have 6 minus I over 2i. 6 minus I over 2i. So this is our last example, and it's a little bit different from the previous examples, such that for it doesn't have the real part, but it's just the same. So you're going to write the same thing, 6 minus I, then over 2i. So to get rid of the denominator, in this case, you don't need to look for, not really, you can look for the conjugate, because we know that let's say this expression is the same as 0. This expression is the same as 0 plus 2i. Okay, 0 plus 2i. So the conjugate of 0 plus 2i is just 0 minus 2i. So 0 minus 2i, that's the conjugate of this particular number. So what you're going to do is, instead of writing 0 minus 2i, you're just going to write negative 2i. Okay, you're just going to write negative 2i, because you know the conjugate of 0 plus 2i is simply 0 minus 2i. So you're going to multiply both the denominator and the numerator by negative 2i. So you're going to say over negative 2i over negative 2i. So when you do that, this is the same as negative 2i multiplied by 6 minus I, and then close bracket, then there you have that. Then here you simply have negative 2i times 2i. So I times I, it's negative 1. Negative 1 times negative is positive, so you have 2 times 2, which is 4. So in that case, you just have positive 4. Okay, let me repeat that part. I'm sure most of you haven't gotten the point. So these guys now, so you have 2i times negative 2i. Okay, so this is the same as 2 times negative 2, okay, times I, for that I there, then e times